Welcome back to this lesson. So this is lesson 3 of domain 1, plan AI power business solution, architect agentic first business outcome with Microsoft AI apps, Microsoft Foundry, co-pilots, Dynamic 365 power platform, and govern enterprise data. So we are still looking at domain 1, plan domain weighting, autonomy, orchestration, grounding, return or business value, ROI, TCO, and secure adoption. All right, the next thing we have on our on our slide here is grounding. So what is grounding? How does grounding make AI trustworthy? So when we talk about grounding, we are talking of supplementing information with another relevant information. So supplementing what the AI is generating with business context, with domain data, so that AI will not hallucinate. That is layman understanding of grounding. So grounding connects, because grounding connects a model response to trusted organization data instead of model memory alone. Okay, so grounding is what connects your model, whether built in Copilot or Foundry. It connects the model with organization data. For like this data can be files, it can be table, it can be Azure SQL database on SQL Server or on Azure, it can be data in the warehouse, it can be policy files, repository of data dumped in Azure Blob Storage or SharePoint or OneDrive. All this information can be in anywhere in Microsoft ecosystem as long as they are the organization data. So grounding connect model response to trusted organization data instead of model memory alone to prevent hallucination. So Microsoft Copilot grounding uses Microsoft Graph. Okay, if you want to connect to this Office 365, Dynamic 365 solutions and database and ERP system, what you basically use is Microsoft Graph. Okay, Microsoft Graph enable you to connect to semantic index, SharePoint, OneDrive, and other ecosystem, connected system like that. So you connect to data repository through Microsoft Graph. And then if you want to connect to Azure, you have to think of using, ABFS connection, SaaS, and using IAM, role-based access control. So Microsoft Copilot grounding uses Microsoft Graph, semantic index, Copilot retrieval API, SharePoint, OneDrive, and connected systems to generate insight from information. It uses this platform to connect information. Permission-aware retrieval reduces hallucination and supports security compliance. So connection should also be permission aware. Give the agent access to only the information it needs. If it doesn't need access to entire repository of company data, do not give the access to the entire document. Put the document in a folder that you want the agent to access and limit the agent access to that document so you can use the document to retrieve company aware information, thereby making the agent to reduce hallucination and incorrect response and support security compliance still. The architect designs grounding paths before scaling agentic use case. So after requirement gathering and solution design, the next thing is you should be implementing and looking at is the data architecture of the business. So you know their data sources, know where the data are. And if the data is not in Microsoft ecosystem, you should know that the first thing to do is to build a data architecture for the company on Microsoft platform using warehouse, using ADLS, Azure Data Lake, or OneLake, or Lakehouse, or Fabric, or SharePoint for files, OneDrive, Unified OneDrive for Office 365 connected system. So connect to SharePoint, OneDrive through Microsoft Graph, connect to semantic index using API and the Copilot Retriever API. So these are what you should look at. So the architect design grounding part before scaling agent. So you should design for grounding, design for data source, design for data or connection before you start thinking of agent scalability. Okay, and the architecture you should consider here, the architecture terms you should consider under grounding is a Microsoft Graph. You need Microsoft Graph to connect to SharePoint, OneDrive, OneLake, and so on and so forth. Semantic index. This is Azure AI Search, either in Microsoft Copilot or Microsoft Foundry. So using endpoints or URL or API. Retrieval API in Microsoft, one of your architecture seated in Microsoft Copilot. SharePoint data. Okay, so that is just like a company repository of files, just like blob storage, where all company files are deposited domain by domain. And then permission trimming. So trim permission down to what the agent need. Do not give permission to entire ecosystem. That is why we talk of domain context or boundary context. So agents should be bounded. So if the agent need access to only procurement data, then go to procurement page on SharePoint and implement the access there. Do not expose the access to other business domain which you are not currently implementing for. So trim down permission to what the agent need for the implementation, not the entire business information. Right, the next thing we have here is data quality. So there are 5 dimensions of grounding data quality. Okay, so how do you ground data quality? So the first thing you should be looking at is accuracy. So is the data correct? Is it verified? Is it authoritative data that prevent wrong responses? You should ensure that the data is correct and the data answers business domain question and it is domain relevant. That's the first thing, because if the data is not correct, the agent will also implement wrong thing and will generate wrong information, and then this will not be good for the business. Relevance. So is the data relevance for the context? Is it relevance for the business? Is it relevance for the domain you are using it for? Data must match user intent, domain context, and business task. Very, very important that data is relevant to the operation. Timeliness. Also consider whether the data is timely in terms of policy implementation, report generation, operations data must be current. Make sure the data is current and timely. Make sure the data can support current policy. Okay, if you are operating or implementing policy data, policy repository of 20 years ago for what you are currently operating, that would be wrong, because the policy that the company implemented 30 years ago may be different from the policy that they are currently implementing. So make sure the data is up to date in terms of policy implementation. In terms of report generation, make sure the data can also support the current report that the company needs, not the report that they used maybe 30 years ago when they still operate certain policies or when they have limited exposure or expansion. So the business might have scale and the data also will have changed form. And then you should also make sure that the data is relevant to the current business situation. Then operations data must be current. Make sure the data is current. Cleanliness. So make sure there are no duplicate data. Make sure there are no duplicate documents because this can cause noise and make the agent to generate repetitive information that is boring and not relevant. So remove duplicate, noise, inconsistent format, and weak metadata. So remove noise. This is where data engineer comes in to process the data, transform the data, and generate useful context, storing them in RAG database so that the agent can easily retrieve useful and relevant information instead of just hallucinating and wumbling about noisy data. Availability. So data must be accessible, indexed, and permission aware. So of course, this is also where the RAG database development also comes in. So make sure the data is accessible to the agent. Make sure the data is properly indexed, embedded, and chunked using vector database like PG Vector or Azure AI Search and properly indexed, or using Cosmos DB indexed database, and the permission aware. Very, very important. Role-based access control. Then also implement governance. So data must respect labels, lineage, role-based access control, and compliance policy. So governance is very, very important. Governance enable guardrails. So put guardrails on the data. So labels must be respected. Okay. So the labels are, the information that the data carry. They must be respected. Human information, customer information, PII, they must be redacted from the AI and must be encrypted. So also track the lineage of the data, where the data is coming from, how it is generated. Also implement very important role-based access control. Give access to the agent only to what it needs, and make sure the agent also complies with policy. Okay, if there are data that should not be exposed to the agent, make sure they are encrypted and the agent doesn't have access to it, and make sure PII information are redacted. All right, so the next thing we have here is retrieval architecture. How do you design retrieval architecture? So retrieval has to come in when RAG database is developed. So RAG database means retrieval augmented generation. It enables, organization to turn historical database into a knowledge base vector database where the agent can access and generate information to augment the information and business decision making. So the process involves ingesting data, cleaning the data, chunking the data, embedding the data in vector store database, and then retrieving the data. The agent retrieve the data from the system to implementation, for augmentation, and for business decision making to prevent noisy information and hallucination. So semantic index converts organization data into meaning-aware representation, not just keywords, okay? So it helps agents generate meaning from data. It helps agents make meaningful decisions, generate meaningful information, meaningful reports, and meaningful analysis of your data and information. Copilot Retrieval API retrieve relevant passages, contextual information, and user-authorized content from the data through Copilot API. We have seen how Copilot API can connect to SharePoint, search index, OneDrive, OneLake, and so on. So source of data for indexing includes SharePoint, OneDrive, Microsoft Graph, and connected enterprise system like RAG database, PG Vector, Azure Search Index, and Cosmos DB and Blob Storage. Retrieval design determine answer quality, contextual accuracy, and security boundaries. So what is retrieved from the data also determine the answer quality, contextual accuracy, and security boundary. So that's why when data is being chunked and indexed, it should be indexed properly. Okay, not you can't put an entire maybe 50 pages in one chunk. So if you have large documents, you can chunk them page by page. If you have a little bit, if you want to go a little bit in depth, you can chunk by paragraph, okay, instead, so the agent can easily retrieve information to determine to improve quality and contextual accuracy, instead of just generating large information that is not currently relevant. Architecture terms that you should look at in retrieval architecture is, first of all, the RAG architecture. Okay, ingest data, clean data, chunk data, embed data, store in vector store, and then retrieval design. So you should be looking at semantic representation. That's chunking, embedding, and storing in vector database. That's semantic representation. Relevant passage. That's generating relevant context like paragraph or word from the system. Then user authorized content. So make sure the content of the RAG database is user authorized. Make sure they are what is accessible to agents. Make sure they do not contain PII and information that should not be exposed. Connected system. Make sure that the system are connected. Okay. System SharePoint, OneDrive can be connected using Microsoft Graph, and other sources can be connected using API. And make sure the data is properly chunked into context. So context implementation are the architecture terms that you should look at under retrieval architecture design. So AI ready data. How do you assess company data for AI readiness? So remember, the first thing, we are still at planning, domain one. So, and planning involves, requirement analysis, investigating data architecture, and then observing data for readiness. So you should make sure that the AI data, the company data is ready for, or agentic AI operation. For example, we are talking about Microsoft domain here. So if the company data is not within Microsoft ecosystem, then that is number one, flash. So number one, they are not ready for AI. So the first thing you should look at implementing is, establishing Micro Office 365 ecosystem, Dynamic 365 for ERP, and using data warehouse like Fabric, and blob storage for for large data, or repository, dynamic DynamoDB for document storage, or for JSON data for streaming, and unstructured data, and all those sources. So that is the first thing. Investigate the company data for AI readiness. Organize business data for AI system. How can you do this? AI system require data that is structured, accessible, governed, and discoverable. Okay, it's very, very important. The data must be structured. Even if it is filed, it must be stored in structured repository on SharePoint, OneDrive, or OneLake. Okay, and then it must be accessible through governed processes, and it must be discoverable. Point number two, poorly organized data weakens grounding, increase hallucination, and reduce retrieval quality. So if the data are just stored anyhow, information are just dumped, no domain boundary, no boundary context, all information, all domain information are just stored chunkly in one repository, that is very bad. Okay, because that will cause the agent to hallucinate and generate wrong information. Okay, thereby reducing retrieval quality. So the first thing is to structure the company data domain by domain, domain by domain. Procurement data should be under procurement folder or page. Supply chain data should be under supply chain. Finance data should be under finance page. HR data should be under HR. IT operation data should be under IT domain. Okay, you can build SharePoint pages where all this data can be stored, or SharePoint list, or using files and folder in OneLake, for instance, creating containers for different departments on Azure Blob Storage, and so on and so forth. There are many ways of doing it. Just make sure the data are structured and stored on domain basis. Okay, standardized schema. So standardized schemas, metadata, naming, ownership, and sensitivity labels. So very, very important. So when the company's data are properly structured in SharePoint, every department have their SharePoint domain. Then the next thing is to implement warehouse. Okay, because there are some data that should be structured, that should have schemas, columns and tables, business metric composed together. So you should be thinking of, okay, warehouse, after SharePoint, warehouse. So, and what comes into mind there? Fabric, unified lakehouse analytics platform within Microsoft ecosystem. That's Fabric, where all the data can still sit in one lake. You have the semantic model, you have the raw, the bronze, silver, and the gold, the raw, the process, transform, and model data sitting on one architecture, which is one lake. And then you have your gold layer, which is your warehouse. You have your lake house, which is where you have your raw data, and process and semi-processed data storing there. So agent can also connect to one lake to get data. So that is the next thing. Schemas, metadata, naming, ownership, and sensitivity. And then in Fabric, you can create domain. You can create workspace for each domain, so that each domain data will be under a particular workspace. So, and then you give access to the workspace owner based on business domain. Then expose trusted data through APIs, graph connectors, semantic indexes, and enterprise search. So as trusted data can be exposed through API, graph connector, semantic index, and enterprise search. Keep source authoritative, current, auditable, and permission aware. Very, very important. We've been talking about the business value you are generating is ROI, TCO, and secure adoption. Secure adoption involves governance, being compliant with policy, and implementing guardrail, role-based access control, least privilege, protecting companies' data, okay, because that is number one, thing that used to scare enterprise off when we mention AI. So you should hammer this and make it grounded. Anything you are doing, make sure it is secure. It is, policy compliant, and guardrail is fully implemented. So keep the source of the data authoritative, protect the source, implement role-based access control, and least privilege. Okay, let your agent have identity and access this. Agents should not even access the system. You should be connecting to the graph using Microsoft Graph. That's why MCP server is there. MCP server are designed to connect to the source, and the agent gets connect to MCP to get information. So using MCP server, which is secure already, we connect to the source. The server connect to the source, get information and send to the client. Agent get information from the client. So agent communicate with the client while the server connects communicate with the source. So there is a bridge there. So MCP is a very good adapter that you can use to connect to the source, and it will act as a bridge between the enterprise system and the agentic AI. So keep source authoritative, current, auditable, and permission aware. Okay, so the architecture terms that you should look at as a AI solution architect here is structured data. Structured data, okay. If the to check whether the company is AI ready, check whether the data is structured, check whether it is discoverable, check whether metadata are properly stored in SharePoint, OneDrive, OneLake, etc. Check if there are graph connectors and API. Very, very important. Okay, and they should be included in your architecture. The next thing we have here is RAG pattern. So we've talked about RAG, and I've verbally explained them, but this is RAG pattern or RAG design, and this is also known as RAG architecture. So retrieval augmented generation architecture flows like this. You have your enterprise data as the source from wherever it is: SharePoint, OneDrive, OneLake, warehouse, lakehouse, blob storage, Azure Cosmos DB, everywhere they are in Microsoft ecosystem. You have the source, enterprise data, then retrieval engine. So this retrieval engine retrieve information from the source and passes it to the LLM. LLM passes the information to grounded response. So grounded response is where the agent combine information from the enterprise RAG database to information from the LLM, okay, ground it together and generate relevant response, combined with citations from other documents and wherever they are, and then gives you action. So this is the entire RAG workflow, okay. This is how it flows. This is RAG architecture in layman understanding. So RAG combines trusted enterprise data, retrieval, and language models. Benefits include real-time context, stronger accuracy, fewer hallucinations, privacy, and enterprise scale scalability. Okay, so which supports correct decision making, strategic thinking, and generated answer quality. Okay. All right, so when we come back next, we'll be looking at the next one we have here. Okay, see you there. Please, if you are new to this channel, kindly like and subscribe to encourage your girl. Thank you.